The research of psychologist John Garcia took the study of classical conditioning in a remarkable direction in 1974. At that time, sheep ranchers in California's Antelope Valley were at war with wild coyotes destroying their herds. The need for a solution inspired Garcia.
Then I met Carl Gustafson, who was a very bright student. On his own, he studied coyotes. I said, you get the coyotes and we can teach them not to eat sheep.
The coyotes were fed mutton laced with lithium chloride, which made them ill. Garcia's coyotes now associated their illness with the taste and smell of sheep meat. The results were remarkable.
And they were off of mutton just like that. One or two trials at the most. The coyotes, they hit the sheep somewhere in the flank or the side of going for the throat, and then they reel back. And it's really kind of comical. The sheep then starts bluffing, and it doesn't have horns or anything else, and the coyotes and the wolves give way.
But would this conditioned taste aversion actually work in the wild?
And so then we put together a mutton bait with lithium chloride in it and wrapped it in wool so that it could be dispensed out in the field. Stuart Ellen scattered those baits along there where they were sure to pick up, and he zeroed lamb kills in Antelope Valley.
This highly adaptive one-trial learning helps ensure our survival. Evolution, it seems, has equipped us to learn some lessons more quickly than others.
A colleague and friend of mine in Sweden, Arne Ehrman, had been studying whether there's something special about the learning of snake fear. You take human subjects who aren't afraid of snakes or spiders or flowers, and you present them with slides. Some of the slides are followed by a very mild electric shock to their hand. He found that when you paired snakes or spiders with mild electric shocks a few times, that the human subjects would pick up a conditioned fear in quotes response as indexed by the galvanic skin response, but when you told them you weren't going to present the shocks, it didn't seem to matter, that they knew that they weren't going to get shocked anymore. The fear was maintained. And by contrast, if you paired pictures of flowers with mild electric shocks, people would pick up the fear, but when you told them you weren't going to present the shocks, their fear went away immediately. The reason people are more likely to pick up fears of snakes is because those who had quickly picked up a fear would have had a selective advantage relative to those who didn't pick up those fears readily, who might be at more risk and didn't stay around to pass on their genes.
This idea of animals negotiating their environment by moving to rewards and away from dangers was critical to the theories of psychologist B.F. Skinner. Skinner became famous for his lifetime of research into a second type of associative learning called operant conditioning.
Operant conditioning pertains to behaviors that operate upon the environment to produce consequences. So the organism does something, and then there's a consequence that's either punishing or rewarding. And behaviors that are rewarded tend to be strengthened. And if the behavior is strengthened by the consequence that follows that, we call that a reinforcement.
Using a system of reinforcement, Skinner was able to gradually shape an animal's behavior. Skinner conditioned animals of many species to perform behaviors based on reinforcement. He claimed that regardless of the species, their response to reinforcement was virtually the same.
And so he said that was the power of his method, that it couldn't tell the difference between a pigeon, a rat, and a monkey.
Examples of operant conditioning are found just about everywhere.
If you think about how we reward employees, then reinforcement theories are very important to helping us understand what goes on in the workplace. People are getting rewarded, and it's done on schedules, just like the rats in the Skinner boxes. And so there are lots and lots of parallels there.